All right, I'm Dr. Allamehzadeh, the Director of the Electronics Engineering Program here at ENMU. We offer a Bachelor of Science in Electronics Engineering Technology and also several Bachelor of Applied Art and Sciences in Eet Program. We also offer Associate of Science in the Eet. We actually have a pretty good program, and we try to involve the students in a lot of projects, a lot of hands-on. And as you see right behind me, this is like a couple of projects that the students actually worked on. And almost all these students graduated, and as far as I know, they have a very good jobs with either Encore, Lockheed Martin, or Sandia Lab. So our graduate usually gets hired by these prominent company in the US. All right, now we also have several other projects over here. For example, this one here, which I show you later on, this is called the solar power golf cart, and they worked on the project, and I think all of them are working for Encore now. It took about 2-3 semesters to put everything together, but actually the students learned a lot, and most of these projects were all funded by STEM. This is another project which is called the solar tracking, and Davi and Jose actually worked on that, and they are working for Encore now too. This one here is a magnetic levitation project, and this one here will actually put together by John was here for a while, and then Andrew. And John now, I think last time I heard, he's in the PhD program in electrical engineering. And Andrew, I think, is working somewhere. So this one here, actually, we did a summer project for the people who were coming from the other colleges in New Mexico, Luna Community College. And actually, they developed a model for that magnetic levitation system. So again, we try to involve the students in a lot of the projects and hands-on activities, so when they are ready to graduate, that is actually will be a good thing for their resume, and most of the time they get the job with the good places like Sandia, Los Alamos, or Lockheed Martin in the base, or Encore, and other companies. And the average salary for our students, for the graduates, has been about $75K, somewhere from $75K to $85K. Okay. All right, we have two actually big labs over here, and in this lab, a lot of the lower level courses and some of the upper level courses actually is done here, and the students will come here, and all the electronic parts are over there. They don't have to buy any parts. We charge them a lab fee of $25 per course per semester, and they're allowed to use any of these parts, any one of these equipments, and each student will have their own station here. So for example, this is the station number 1 for one student. He has access to the oscilloscope, he has access to the function generator, and he has access to the DC power supply, and also a computer which is connected to the network. So like for example, here is like a project. This is the communication project. This is how you generate AM signal, and a student work on it. Usually we ask the students to put everything on the breadboard. So they actually put all this stuff on the breadboard. Again, this is oscilloscope, this is function generator, this is your DC power supply, and the students will put all these things together, and in case they need any help, actually we will help them out with the troubleshooting their circuit. So again, every EET courses that they offer here has a lab. So 2 hours lecture, 1 hour lab. So the students get a chance to practice a lot as far as the hands-on is concerned. This lab has 24 stations. So we can actually accommodate 24 students here, and again, these are all the electronic parts that students are allowed to use, and the same thing over there. And we have actually another soldering station over there. This is mainly for the students who actually work on their capstone projects. See here, this is for the students who work on the capstone. They can actually solder their final product, and they will be able to present it during their last presentation in the course. Again, see that one over there, actually this is students work on a project. This is for a cane for a hearing impaired, the visually impaired person. And he put everything together from scratch, and he demonstrated that in the capstone project. Okay? So, and then there's another project here. While we're here, let me show you this. This students has been working on this project since the last semester. Brandy Duff and Damilola Kunu and also Michael J. Fox first worked on this the last spring. And this semester we have the Julia Chavez and Damilola Kunu again, and the Lene Billy work on this project too. This project actually is based on what they call the wireless power transfer. How do you transfer the power wirelessly through the air? So we have two coils here, so let me plug it in. And we have two coils here, these two coils. The power actually comes from the outlet over there, go through that circuit, and will be converted to some form of AC, and will go through this circuit here, and this is our transmitter. It will transmit the power through the air. This coil here actually has no connection to the other circuit. It will pick up the energy through the air, and what you see over here is this here. It comes from this loop over here. So do you see, as we increase the distance, the power will get basically weaker and weaker. You see the light bulb, and we actually managed to make pretty good distance. This is almost like 15-16 inches of the distance between the coil. A lot of projects actually, they did this with no more than like a few inches. So, and the idea is this: what should be the relationship between the size of these coils and the distance between them for transferring the power? So students actually researching that, and so far we have been very successful. And students actually see, these are all made by the students. These are the coils that made by the students, and there are several different sizes. So we check the relationship between the diameter of this coil and the distance between these two loops. And as you see, as you increase the distance, because this one has a bigger diameter, actually the distance will be bigger. The application of this one here is probably some of you already seen in the cell phone charger. You can actually put your cell phone there and basically get charged wirelessly. Another application of this project is in the electric car. You can actually drive through and your car will be charged. And also charging basically the pacemaker, the battery for the pacemaker. So this way they don't have to take out the pacemaker. They can just charge it through their body. Okay? All right, so thank you, John. All right, so this is actually a wind lab which we use for the renewable energy courses. We're going to have some more equipments probably, hopefully by the fall, another lab which we'll show you later on. But this one here that we use for the EET 402, which is the first course in the renewable energy. Now, this one actually was purchased through the grant from STEM. And it's basically, you have a wind tunnel and you have a wind turbine. And let me start it. basically the apps. So the students will actually get a chance to come here and do this labs. By adjusting the wind speed, they should be able to investigate the relationship between the wind power and how much electricity actually is generated by this machine. And also over here, you could see everything on the laptop, and this laptop will also record all the information into a file. So later on, if you want to do it for research, you can. So this is one of the tools that we use to teach the students about the renewable energy. And so far, I mean, it has been good. We're going to have again more equipment and more tools to train our students to their emphasis in the renewable energy, which starts in the fall. Okay, so this one here also is our second lab, which is how some of the equipment mainly for the upper level EET courses. For example, this one here is for EET 302, which we call Industrial Electronics. Here, this is what they call the PLC, Programmable Logic Controller. It's heavily used in the industry. Its main function is to automate the process. So cheese plant, for example, here they have like 6, 7 of these, and everything in the cheese plant is run automatically almost. It's just through these things here. We teach the students in that course how to program this and how basically to use it for the EET 302 course. And we have, I think, about 12 stations over here for the students. And again, they get to practice, and we do a lot of hands-on over here. There is another one, the station over here. This one mainly for the microcontroller and microprocessor, which actually they were all put away. And again, the students, 12 station over here, the students will be able to come during the lab time and do all their labs over here in this area. We also have this thing here. All of these actually are made by our students. They are the one who put it together. This is we're going to use this for the lab for EET 450, which is the control system. Actually, this one here is the original one that was designed by us here at ENMU. And this is a magnetic levitation system. Unfortunately, again, these kids came and messed up with it. So basically the idea is this. You have a magnet ball, and at a certain distance from this coil, we design a controller and put some circuits together so it will be levitated in the air. So the person actually who worked on this for like 2-3 semesters, his name was Robert Jimenez. He's actually working for the Sandia lab. And last time I heard, he has a pretty good job, and he's making over 6 figures over there. We're going to use the same technique in those here for the EET 450 in the spring. So we're gonna go over the course, and this become like a project toward the end of the course. A student's supposed to design a controller so the ball will in the air will be levitated. So these are all, again, the station that we have, and all of these are put together by students. This is another project that actually the students worked on a while ago. This is called ball and beam. And basically you put a ball somewhere, and the controller, which is all in here, all the electronics part is inside the box. It will be able to move this up and down until the ball is right at the center. Okay? All right. And this is again made by students. Okay. Thank you. All right. This is another project that actually 3-4 students worked on, and again, I guess most of them they work for Encore Power Company now. This is what they call the solar power golf cart, which you already saw basically the poster over there. And this cart is designed in a way that if you take it outside, it should be able to use the solar power to power the motor in the golf cart and also continuously charge it up. So technically this cart, as long as it's driving out there, it will continuously charge up itself, so you don't have to plug it in. Also, another feature that we put into this card was that it has a voice recognition. So you can actually talk to the golf cart, start, turn on, turn off, and this one here, when you take it outside, actually you can raise it through a command to, when you say raise, actually this will go up, and when you say lower, it will bring it down. Again, all of these were put together by the students, and this card was actually a donation from the Mr. Lee Quick to the students, and we appreciate it. So again, most of the projects here are funded by the STEM office. So the students actually got paid to work on this project, and most of them, they got jobs because of these hands-on projects or labs that they involved in the program. So this was one of the projects that they worked on. We also have another project. This one here, this is a solar tracker. This one is again designed in a way that when you put it out there, it will track the sun and will get the maximum energy from the sun and convert it to actually an AC electricity which can be used. So here you can actually plug in, we plug in fans, radio, anything you want to plug in here. This becomes like 110 volts, exactly like the outlet in the wall. This is actually the circuit that these kids, they put together. And I remember they worked on this for like 3 semesters. I know one summer this kid, Micah, actually came here and we actually made this a complete project. And unfortunately, because of that COVID situation and everything else, we were able to use this for a while until this situation is over and the students will come back and work on this. But everything again is designed from scratch. We put everything on the paper first, tried it, and then we built it here. And again, this one also was funded by the STEM, and I need to have a special thank actually to Robin and to Ken for giving us this opportunity and this fund so we can actually have the students work on these projects for us. All right, we actually offered the EET program here at the ENMU hybrid. It's for face-to-face student and also 100% online. We have a good number of students actually that are working full-time and they are in the program. All the lectures that actually we do here in the classroom will be all recorded, and the people online have the opportunity to basically watch the lecture at their convenience and do their homework. And we have also a lot of tools that the students can use if they need help. For example, like I tell the students, basically if you have any question, send me your question prior to the lecture and I'll be able to go over that in the next lecture. Now we offer a Bachelor of Science in EET. We also offer a Bachelor of Applied Art and Science, and this is designed for someone who already have an AAS degree from 2-year colleges, or they have some relative experience in the technology, and they can transfer to this program, and it should take about 2 years for them to finish the degree. And we offer the BAS degree in analog electronics, digital electronics, analog and digital. We offer now a BAS degree in computer engineering technology and also a BAS degree in renewable energy. From this fall, we're going to also offer an emphasis in renewable energy, which that means the person can actually get into the program. Again, we have the BAS one and we have the basically with the emphasis with the Bachelor of Science. So they can finish the degree within 4 years if they start with us, or if they transfer, it depends on their background, maybe 2 to 3 years to finish up the program. We're going to have actually a pretty good number of equipments for the renewable energy emphasis from the fall, which will be housed actually in that lab in the next door. So we're going to have 3 labs from this coming fall. And those who are on campus, actually they can come here and basically work on their labs and other projects. In our lab, we have also some opportunities for the students who are living around this area, like Roswell, Clovis. They still have the opportunity to come here like once a week, maybe Fridays, and basically work on their labs and work on their projects. But it is 100% online, so you don't have to be in New Mexico. You can finish everything up online, and we are one of the most affordable school, I guess, in the Southwest area.